Today we are going to look into norms, and a norm, at least in simple terms, is just something that measures the length of a vector. Okay. We'll also see, though, that we do have norms for matrices. There is a mathematically rigorous definition of norm, but we're not going to dive into that. Just note norm essentially means length in some way. Okay. So let's start off with the most common norm here, the Frobenius norm. Okay. And we're going to see how we can input that into MATLAB. Okay. And I want to also point out what it is here in a second, but we're going to need a vector. How about we use the vector 1, 0, 4. Okay. There we go. So if we were to take the Frobenius norm of this, we could do this actually in multiple ways. So one is we could use the norm command, okay, and we could type in our vector, and then in here we would need FRO. Okay. And let's see what the output looks like, see if we can figure out what this norm actually is, because all we've said is it kind of means length when we're speaking generally. Okay, so it gives us this 4.1231. Okay, this should look a lot like what you're used to using for finding, say, the length of a vector. If I were to take the square root of 1 squared plus 0 squared plus 4 squared, you'll see that we get the same thing. Maybe I'll call this one answer 1 and answer 2, and we should see that they give us the same number. Okay. Just go ahead and move that command window up a little bit. Okay, good, they look the same. Okay. And I want to put in here what this really is. The Frobenius norm is the square root of the sum of the square of each element. Okay. Right, we summed up the squares of each element and then we took the square root of them. Okay. So the question is, well, how's this look for a matrix? Okay. And it will work in the same fashion. Let's make a small matrix here, maybe just a 2 by 2, so the addition here is easy. How about we do 1, 0, 2, and 3. Okay. So there's A. So if this statement here holds, that we put here in parentheses, then this should end up being the square root of 1 plus 4 plus 9. Okay. And so let's check and see if we get the same thing here. I'm going to maybe say answer 3, answer 4, okay. And we'll do norm, and this time A, since we're working with our matrix A, and FRO in quotes. Okay. And then also the square root of 1 squared plus 0 squared plus 2 squared. That's not a 2. There we go. 2 squared plus 3 squared. Okay. And we're going to hope that those two are the same. Okay, but we're only going to have it output those two. Okay. All right, and we can see that they indeed are. Okay. But I want to point out something else here, which is that there's something also called the 2 norm. Okay. And so the way that we could type that in, maybe I'll call this 3 this time, which means I need to change these to 4 and 5. 4 and 5. Okay. And I'm going to suppress these, and then I'm going to unsuppress the first 3 here. Okay. So we have something called the 2 norm. Okay. And this is just really indicating that we'll be squaring the elements and then taking the square root in the end. That's what this is really signifying here with this 2. Okay. And we should see all 3 of these giving us the exact same result. Okay. All right, all the same one. Now let's maybe talk about some norms that are a little bit different. Okay. Let's focus in on the vectors for a moment. Okay. So let's say the 1 norm for a second here. Guess this puts us on to answer 6. I'm going to suppress some of this stuff. Okay. And let's take the norm of the vector x, and again, this is going to be the 1 norm. Okay. Let's see what this gives us and then see if we can figure out what it is. Okay. So we'll go ahead and we'll run it. Okay. You see we got 5 here. Let's look back at our vector x. So it's just the sum of all the elements. Okay. And specifically, if I were to change this to, say, a -4, you still get 5. So it's the absolute value of those elements as well. Okay. Alright, and we have another one called the infinity norm. Okay. And I'm going to also say for a vector. Okay. And in this case, this is going to, well, we'll find out. Let's do that. And we actually haven't typed this one in. Confusingly, you have to type in the quotes around FRO, but for INF we won't have to do that. Okay. This is how we do the infinity norm. Okay. Okay. And you can see we're getting the answer of 4 down here. And so if you were to look up here, 4 appears to be the absolute or the largest element, and to be more specific, the element whose absolute value is largest. Okay. The element with the largest absolute value. Now let's try out some of these other norms on some matrices. Let's maybe try the 1 norm. So we're up to answer 8, and we have the norm. We have our matrix A, comma 1, and maybe I'll move our matrix A down here so we can see it. I already have it defined above, so I'm just going to comment it out. Alright. So let's see what we get after suppressing answer 7. We get a 3. Okay, so the question is, what did that do? it appears to have given us either the largest element in A or the largest sum of a column, but it's not clear because of the answer that, or the example that I've chosen here. So maybe let's edit A a little bit more. Let's make it a little bit more complicated for this example. Let's try and we'll add another row to this. Let's use that, and I'm going to copy and paste it just so it's right in front of us with what we're doing. Okay, let's try this one more time. So what we have here is 10. So the question is, where did that 10 come from? Well, that looks like from taking and adding up everything in each column. So the first column, if we were to take the absolute value of everything and add it up, we'd get 10. And if we were to do that with the second column, we'd get 4. And so the biggest of those was 10, and so that's what's been output here. I don't think I'm going to be able to word this one as briefly as the others, so let's see here. Okay. A summation of the absolute value of the coefficients is performed for each column, and the largest of these summations is taken as the norm. Okay, and let's do another one here. Let's go ahead and we'll try out the, how about the infinity norm for this matrix A. Okay. Remember, we just need INF here. Okay. Let's suppress this and see what our result is. Our result is 8. 8. Okay. So what do you think it was doing here? Looks like the same thing, but for rows. Okay. Just for rows. I'm just going to change the word column to row on each one of these. Largest. All right, perfect. Okay, and so there are still more norms that we could take. I didn't do the 2 norm for matrices because this is going to have to do something with eigenvalues, and we're going to talk more about eigenvalues here in I think chapter 13.